All right, with trial and error factoring, it is the opposite of the full method. There is not a greatest common factor I can factor out of here. I have 3 terms, so I can't do grouping. It is not a perfect square trinomial. 10 is not a perfect square. So let's break down all the rules that we've talked about. If you have 3 terms, you can do 3 things. I would write this down if I were you. Number 1, you can try greatest common factor. Number 2, you can see if you have a perfect square trinomial. And number 3, which is what we're going to learn today, you can try trial and error.
What's PST again?
Perfect square trinomial. Now that's what we talked about on Friday. To be a perfect square trinomial, you have to have a positive perfect square first, a positive perfect square last, and what you square to get this times what you square to get this double, give you the middle. We don't even pass the second test here, that's not a perfect square. By the way, if you have a binomial, you can do 2 things. Kind of interesting how that works out. Trinomial, you can do 3 things. Binomial, you can do 2 things. You can always look for a greatest common factor. Or what's the other thing you know you can do with a binomial? We talked about it Friday.
Difference of 2 squares.
That's right, the difference of 2 squares. If you're factoring a trinomial, you can try 3 things. If you're factoring a binomial, you can try 2 things. I would keep that in mind. I don't even write at the top of my test, here's what I can do. Okay, those are the things I can do. All right, that gets us back to what we're talking about today, is this one right here, the last effort on a trinomial. If I don't have a greatest common factor, I don't have a perfect square trinomial, or, hey, I could have 2 of these, I could have a greatest common factor with one of those, right? That's possible. I could have a mixture of things here. But here's what happens. With trial and error, you're trying to figure out what 2 binomials that you would foil to give you this. All right, so you ask yourself, what do I multiply by itself to give me x squared? X and x. If this last sign is positive, that means that my binomials have like signs, and I look at the middle to figure out what like signs I need. Okay? If my last sign is positive, think about it. When I do last, when I do first, outer, inner, last, don't I need like signs to give me a positive 10, right? All right, so what like signs do I need? I need this positive right here in the middle. That's where that comes from. Next, I need to think about the factors of 10. Well, there are not many choices. 1 and 10, 2 and 5. Which of those would I foil to give me 10 at the end, but when I do outer and inner, because I've got like signs, I would add to give me 7. 1 and 10 or 2 and 5? 2 and 5. Does it matter whether I put the 2 or the 5 first? It does not. Now, it would be foolish not to check this because it's so simple to do. Always, when you're doing what does trial and error mean? I'm going to try, and then what's probably going to happen? I might make an error. Today, I'm just going to show y'all the best way to try not to make an error. I'm going to try to show you every shortcut I know, okay? But guess what? Sometimes you're still going to make an error. With trial and error, well, sometimes you use more eraser than you do pencil, okay? That's just the name of it, trial and error. You're going to mess up sometimes. I'm going to try to help you not to, but here when you do first, outer, inner, last, and these add to give you 7, you know that this is the correct answer. Okay? But foil it to check it and make sure that we got the right answer. So when that last sign is positive, we're going to have like signs. Let's look at this one. I don't have a greatest common factor. 6, obviously I don't have a perfect square trinomial, right? Alright, so I'm going to try trial and error. We have 2 binomials. What would I square to give me m squared? What does this last plus sign tell me? Like sign. And when I look, what are the like signs going to be? Negative. And then I think of factors of 6 that because I've got like signs, I'm going to add to give me 5. And they would be 2 and 3. Alright, first is m squared. Outer is negative 3m. Inner is negative 2m. Those I add to give me negative 5m. And last is plus 6. So hey, that is the correct answer. Okay? We're not using our book today. You can put that up because it doesn't really have any good examples in it. I'm using an older book that had some really good examples that breaks this thing down a little baby steps at a time. Alright, so let's look at this. This problem is different in that it is not in descending order. It needs to be in standard form before we start. And so what form do you think I should put this in? How should I do this? A squared what?
Minus 8a.
That's right. That's right. Good. Okay. Now, the last term is positive. There is not a greatest common factor. This is not a perfect square trinomial. I would square a to give me a squared. I need like signs because of this positive at the end. They both need to be negatives. Alright, so I need factors of 12. Again, that I would add, because I've got like signs, to give me 8, and that would be 6 and 2, 2 and 6. Again, doesn't matter which order you put them in because both of these are 1/8. Now that's going to change when the number in front of your square term becomes something other than 1. That makes things a little more complicated. And that's when we're going to do that bottoms up factor I was talking about. But first is a squared, negative 2a, negative 6a, like signs, add, give me this middle, and at the end, last, would give me plus 12. So there you go. What do you think about it so far? So far, so good. Okay? Sometimes I have more than one variable. No big deal. This is in standard form because I go alphabetically. A squared, A to the first, no A at all, right? So I don't have a greatest common factor to factor out. 12 tells me this is not a perfect square trinomial. Not a perfect square at all, 12 isn't. So I need an A here and an A there. I need like signs, and they will be positive. This time again, I have a 12. Which ones of those would I use to multiply to give me 12, but add to give me 7, 3, and 4? But I've also got this b squared. So it's not just 3, but it's 3b and 4b. So how's that work? Let's foil it. First is a squared. Outer, if I put these in alphabetical order, is 4ab. Inner is 3ab. And last is 12b squared. Hey, that's exactly what I needed, right? Can you see how the student that does not know their multiplication tables just could not do this? They just can't. It's terrible to teach. Yes?
How do you know, like, whenever you're in the 12, like, how do you know how much?
Okay. That's where the trial and error comes in. You say, okay, what would I multiply to give me 12? Here's all my options. But I need to, because I've got like signs, I need them to add to give me this number. Well, that would be 13 and 8 and 7 if I add them. So that's why we use this one because I'm only going to turn to 7. Okay. Very quickly, I'm going to give you a few minutes to try some. If you'll try these 5, that'd be great. Very good. So far, so good. would you do before you ever did all that? Do you remember what form you put
Put
it
it
in?
in standard form.
Good, put it in standard form. That's very good. All right, and number 5. Get your parentheses and your B's. Good. And 13 times 5 is 65, but 13 plus 5 is 80. There you go. On a number like 65, especially, well, on a number like 9, how many of y'all put 3 and 3 and got stumped? I mean, a bunch of us. I was walking around, okay? It helps to list the factors of that last number, especially the bigger they get. You know, it could get to the hundreds, you know. So the bigger they get, then the more helpful it is just to list the factors of that number, okay? You might not think of 13 times 5 being 65. All right, so far, all that we've worked had a 1 as a leading coefficient and a positive at the end. All right, so let's take a step forward and change things up a little bit. The plus sign is now gone, okay? The plus sign in the end has changed to a negative, and here's what happens. Okay, I do not have a greatest common factor to factor out. Minus 10 tells me obviously this is not a perfect square trinomial. So I'm going to have to try trial and error, and I need a 1x and a 1x to give me x squared. When this last sign is negative, make note that you will have different signs. And it does make a difference which order you write them in, but you don't know when you start. So here's where I was talking about earlier, trial and error. I'm going to try it. I'm going to miss it a lot, but then I'm going to go back and fix it, okay? So I need different signs, and it doesn't matter what you put first. And I need factors of 10 that I would now subtract. Why subtract?
Because they're different.
Got a different sign. That I would subtract to give me 3. So out, 5 and 2. All right, what's this? Don't write this down. But if I put a 5 here and a 2 here, am I going to get it right?
No,
Do you know why?
because 2 minus 5 is -3.
So I'd have a negative 5 and a positive 2 give me negative 3. Here's the deal. Anytime, even when we're doing bottoms up, and I'm saving that to last, because that's the, going on down the line, getting harder and harder is what we're doing today, okay? When you can fool the binomials out and get the right numbers, but the wrong sign in the middle, just switch the signs and leave everything else alone, okay? So when you can fool it out and get the right numbers with the wrong sign, all you do is you come back and you just, change your sign. That goes from, really I'm talking about bottoms up factoring more than this, because you could switch the numbers on here too. But first is x squared, outer 5x, inner negative 2x will give me the 3x that I wanted, and last, the reason I have opposite signs is I need a negative 10. What if I wrote x plus 5 and x minus 2? Does that matter? No. No. Okay? They can be in different order. Just the factors have to stay intact like they're supposed to be. Alright, let's look at this one. A squared minus 5a minus 24. Alright, I don't have a greatest common factor. A to 24, this is not a perfect square trinomial. It's negative at the end, tells me what? Different signs. Alright, 24 has several factors. And again, it's helpful to list them. Which one do I need? 3 and 8. Alright, tell me, what needs to go with this negative since that 5's negative?
3.
With the negative?
Yep.
And
If I put the bigger number here, negative 8 and positive 3 give me negative 5. Do you see that?
so I say no. That's
Alright, so if I'd have put a minus 8 here and an a plus 3 here, would that have been okay? Yes. But what if I'd have put an a plus 8 and a minus 3? That's not okay. You see what I'm saying? I'm wanna make that really clear. Sorry if I'm making it too clear, alright? Make sure everybody understands. Alright, let's keep practicing with these negatives on my end. Sometimes I have problems with more than one variable, but that's okay. I don't have a greatest common factor. This is not a perfect square trinomial. I need an M here and an M there. I need different signs. I need factors of 14 that I would subtract to give me a negative 5. So what needs to go here? The 7. And not just a 7, but I've got an n squared here. And I'll be honest with you, if I was taking this test, that's what I would miss. I get concentrated on my numbers, forget I've got 2 variables, so don't forget that you need an n times n to give you an n squared, okay? So first is m squared, outer is 2mn, inner is minus 7mn, and you say, well, that's nm, not mn. Does that matter? What property says you can multiply in any order? Starts with a C. Commutative. Alright, so if I add those or subtract those, I get a negative 5, and then last is negative 14n squared. There it is. Questions? What do you think about trial and error so far?
Love it.
It's easy to watch,
Bay.
but, oh, well, good. It's easy to watch, but when you have to do it yourself, sometimes it's a little challenging. Would you try these 7?
Yeah, I got it.
I got really messed up when it had like a variable on one of them and not a variable on the other one, like number 3.
Okay.
Yeah, can you help me on number 3?
That's when you do this.
Yeah.
But you list those factors. Alright, do you guys agree? Alright, good job. Next. Hand the pen off there, please.
There are. Oh yeah. Oh, what's me?
They already did. Yeah. These are the first few you get done on. So probably today. All right, next. You guys agree? Uh-oh. Yep. That's right. Because if you do positive 3ab and negative 9ab, that gives you negative 6ab. Does that help?
Is it okay if I did A plus 2B and then A minus 9B?
How does it
As
get
long as the
A
sign
right
stays
there?
with the term. How do you
Like negative 6ab,
Uh-huh.
like the A.
Because negative 9ab and a positive 3ab, BA and AB are the same. When you multiply,
Is that not just B though?
at the end you need a B squared, so you're going to have 2. I'll show you. Let me full it out and you see. You full it out on your paper. That is good. Very good.
She's recording.
Is there a door slammer? All right. And any of these you don't understand, foil them and see if you get the problem back. If you got something different than these, foil it and see if you didn't get the wrong answer at the end, okay? That you have to fold the check. That's why this is called trial and error, because we do mess up. Alright, very good. Good job. Alright, now let's looking at this one, I'll speak correctly now. This is a squared. This is 3ab. This is negative 9ab. And that gets you your b to the first. But to get this b squared, you gotta have last, you gotta have both of them. And b times b is b squared. And these would go together to give you the negative 6. Same thing's true right here. If I do first, that's r squared. Outer is 9rt. Inner is negative 6rt. And last is negative 54t squared. And 9 minus 6 is 3. So you have to list your factors on the last number, even though I know it is a tremendous hardship and difficult to write all those things down for some people. But you do have to pull it to check it. If you don't, it's just kind of like taking a stab in the dark and hoping it was right. But if I could know for sure I got the right answer, why wouldn't I? Why wouldn't I pull it out and know that I'm correct? All right, so far, every problem we've had has a 1 as a leading coefficient. Now that's not true. Okay, so I could do trial and error here, and that's what I've taught for years and years, to do trial and error, figure out the factors of 2 and the factors of 5 that would FOIL out to give me the right answer. And then Coach Swinford showed me a different way to do bottoms up that's like surefire 100%. So I think y'all would probably prefer that. It takes less thinking, and for some people that'd be great. So let's try that. All right. So what I do now, this is called bottoms up. Well, that's what he calls them anyway. You take your leading coefficient, and the lead is the leader, right? So the leader, I go back here and I multiply. Man, I just made that thing look a lot easier. I am in no way saying that this is equal to that, okay? Don't get confused. I'm not saying, I'm just not inadvertently just changing stuff to be changing it. I'm just playing around with multiplication in the factors so far, okay? I don't even have any great mathematical reason, really, other than I've multiplied, and what undoes multiplication?
Division.
In the end, I'm going to divide to undo that multiplication I just did, so everything stays equal and good, okay? So, but this made it easier. This type of factoring I could have done a few minutes ago. What goes here and here?
X.
What does this sign tell me?
Different.
Factors of 10 that I would use.
Five
Good.
and
What
2.
goes here?
5.
Alright, now, that would FOIL to give me this, right? But I don't want that. I want this. I multiplied by 2 a few minutes ago. Now I'm going to come back at this part. So I multiplied, if you're writing out some steps, by the leading coefficient. Now I'm going to divide by that same number. Alright, I multiplied by 2. Now I'm going to come back and take my factors and divide them by 2. This is actually a perfect example because it has one of each. It has one that reduces and one that doesn't. Alright, if they reduce. Okay? If they don't, this number is on the bottom. I'm going to take it up. That's the name, bottoms up, okay? This 2 is going to go from the bottom up here. All right, first, outer, inner, last. All right, here it is. 2x squared minus 3x minus 5. So this is my correct answer.
Sweet.
Foolproof. It works all the time. All right, now what would you say if I had a problem that didn't have a greatest common factor, I couldn't do grouping, there was not a difference of two squares, there was not a perfect square trinomial, and trial and error would not work.
You do this, bottoms
What
up.
do you call it?
Bottoms up.
Prime.
Prime.
Whoa.
Bottoms up is trial and error, okay? Bottoms up is trial and error.
Goodness.
Alright, let's look at this one.
Aren't you glad to know that I'm participating in class stuff?
I am so glad. Alright, this is not a 1. So I'm going to take it here and multiply. But don't worry about it, because remember I'm going to undo it in just a moment, right? Mathematically, we're going to undo that multiplication. Alright. What goes here and here?
X.
What about my signs?
They're both plus.
This tells me like signs, this tells me what. Alright, factors of 18. Gee, that's going to be tough. That I would add to give me 19.
Oh,
Yeah,
18
it is. 1 and 18. Alright, over here I multiplied by 6. Here I've got to divide by 6. Alright,
Miss Green.
on this one, if it reduces, let's reduce. And if it doesn't, bottoms up, okay? So what do I have to do on this first one?
6x plus 1.
Yeah, bottoms up. So 6x plus 1. But this one,
X plus 3.
x plus 3. And I check it. First, 6x squared. Outer 18x and inner 1x give me 19x, and last is plus 3.
So Coach Smith pretty invented that.
No, he found it and showed it to me.
He
Found it
invented
online or
it?
something.
So you would never leave it.
That would be cool. Anyway,
Tough though.
alright, let's look at this. Alright. I don't have a greatest common factor. If I did, like let's say this was like 18 or something, I would factor that out, but this is a 1. So because this is not a 1, I do multiplication here. So x squared minus 1x minus 72. Alright, would you factor that on your paper with trial and error?
Wow.
It helps. And then when you see it, you're like, duh, right?
Uh-huh.
The smaller this middle number is, let's see if this makes sense to you. The smaller this middle number is, the closer together on the number line you'd want your factors to be. Those are pretty close together, right? Whereas 1 and 72 are far apart. Alright, so I need different signs. And -9 and +8 would give me -1. Although 72 has many factors, right? Although I don't have this one right. This is a 24. Sorry, guys. Sorry. Messed up now. And I missed 4 and 18. Yeah, good. That would have been my luck. That'd been the ones that you're using. Y'all know your divisibility tests. Those help when you get into numbers that are bigger. All right. Well, I multiply by 6 there. Divide by 6 here. Now, let's say this. If they reduce down to an integer, I don't do the bottoms up, okay? But if they just plain reduce a little bit, I want my factors to be reduced. And so since 2 will go into both of those, let's see, do I want this to happen here? I think I do. And 3 will go into both of these. Yeah. I want to reduce, but they didn't go all the way to an integer. So I'm going to do bottoms up here and here. So this will be 3x plus 4 and 2x minus 3. Let's see if that would give me my original problem. Alright, 6x squared minus 9x plus 8x will be -1. And then 4 times 3 is 12. Does that work?
So always try to reduce your fraction before you do bottoms up.
Yeah, and then, but if it goes to an integer, you don't do bottoms up, because there would just be a 1 on the bottom anyway.
Right.
Right, so this is a lot simpler than doing this. And forgive me, I said I wasn't gonna do it, but I'll do it anyway. And this is a 12 on this side. Without bottoms up, you list all the factors of the first number and all the factors of the second number. And you keep plugging them in until you figure out the right combination to pull out to you the answer. With bottoms up, you don't have to do that. I mean, really, it's like robot. I mean, it's like you're a robot. You're just doing the same thing every time. Whereas if you're doing trial and error, you're plugging it in, you're seeing if it works, you're changing things until you finally, figure it out. So that's why I was saying, if this middle is a small number, then I would use the factors that are very close together to start with and see if they happen to be the ones that work. But sometimes that doesn't work. It's not 100%. All right, would you just try one, work ahead of me here and see if you can do what you're supposed to do. See if you can do that one. And I'm gonna kind of stay back, work behind you a little bit.
Use a calculator.
Oh, yeah. Why is it okay that I multiply to begin with? Mathematically, why is that okay? Because I'm going to do what?
Divide it
I'm going
in.
to end up dividing to take it out, okay? How'd you do?
I didn't get that.
Now, if you have 4x minus 1 here and x plus 5, 15 there, it's okay.
I got it right, so that's fine.
Oh.
Okay. That's good, because when you get to the end and you FOIL it out, you'll see that. You just, I got all the right numbers but all the wrong signs. Okay, switch them. That's an easy fix, If all the numbers are right, that goes back to what I'm glad you actually did that. If all the numbers are right but the sign's wrong, hey, easy fix. Just switch the signs out and you got it, all right?
I got to, I had my signs wrong and I went ahead and divided by 4. And so it was all jacked up. I messed up.
Okay. All right, I've got 7 to try. I need some more dollars, so I'm writing IOU list up here, okay, and I'll give it to you tomorrow. All right, here we go. All right, number 1.
The guy got
Let's
the
go.
baby sharks out
You
of
ready?
the big shark, and it set them free in the ocean. Say that again. It's only green. It's sweet.
Goodness. There's that
Whoa.
problem. That's the 30x squared.
That's not the right one. Help.
Yeah, that'd probably be easier.
Okay.
All right, you multiplied, but you
Oh.
forgot the divide.
Sorry.
No, that's fine. That's fine.
This is really soft.
Y'all agree? 3x squared plus 2x minus 24x will give me negative 22x, and negative 8 times 2 is negative 16. Very, very good.
Still not even close today.
Alright, are you ready?
I need help,
Alright, well, come on.
but kind of.
I will help. Alright, she's going to do number 3. These are big numbers.
What if that's the girl's name doesn't look it?
Are they both negatives?
I don't know.
See, that last one's positive, you know? So, let me help you. Yeah, that like signs.
You have to swap it out.
Make it go up. Have you tried some factors?
Yeah.
Just get your calculator out and start at the bottom again to save. $15 and $32. All you can do, once you list all the factors, and she had a bunch listed, but 15 times 32 was not on our list, but they add together to get 47. So now she's going to divide by 24, reduce what she can. So 3 will go into both of those, so that'll be x minus 5/8. Put that in parentheses. And then 8 will go in the next one, x minus 4/3. And then do bottoms up. That's it. Alright, that's good. And that's what you have to do. Some of them you can't do in your head. Okay, and that's one of them, for sure. You just have to get that calculator out and do some division. Is anybody else ready for their problem? If you are, come ahead.
The hiccups.
Did you forget your x squared? Your squared? X squared?
Yeah, I'm like, there's X,
That's the x squared right there.
square.
She's already put it in parentheses.
Yeah.
Oh, you are?
Yeah.
Oh,
That's what I was
She's
like.
a little far ahead. Just like me. Pretty smart.
I really like that shortcut where you put the 30 at the end, to be honest.
Wait, I did the wrong part. My mind.
So we got bottoms up on the first one, 6x plus 5. And the last one you reduce. There you go. Alright, who's next? Come on down. Go ahead. It don't matter. Number 7 is prime. Nothing works. Nothing works. Who's next?
There you go, buddy.
Who else is finished? Come on ahead. Whoever. Both of you. One of you. It doesn't matter.
Orange.
I'll give progress reports tomorrow, but if you want yours early, if you want to come in your third block today, I'll do that, okay? These are huge numbers right here.
Is that stuff like Friday when you're doing with this?
On the test?
Like on that?
What'd you say we're coming in here third block?
I come here in third block and you show me how to do that.
Yeah,
'Cause I
yeah,
completely forgot.
Yeah.
What's the last test? Did you grade the last test we did?
Oh, I had
That would be great for
Can you bring
bonus.
2 packs? Because Mr. Robinson only lets you bring 1. And
No, just one's fine, but if you, yeah.
If we're
Alright,
doing two,
your
we get more.
assignment, guys, is in your packet.
Yay.
And listen to me. Listen to me. This is not the right day to copy the answers out of the back of the book. It's not. Sit down. Sit down. It's not the right day to get somebody else's homework. You need to know how to do this yourself. Okay? Finish up those 7 problems from the notes and do these. Have a good day.
Who are you talking to right there?